Okay, so the topic that we have for today is a very interesting topic because it is different from all the reactions that we have seen so far. So, in all the reactions that we have seen, we always say that electrons are involved, right? It's always electrons. So, for example, when you have ionic bonding and you're making ionic bonds, how does that happen? How is an ionic bond formed? I'm not saying what ionic bond is, I'm just saying how is it made? So ionic bond is made when there's a transfer of electron, right? So usually metals give electrons to non-metals and they accept electrons. Okay. And we say that things that give electrons, they are called metals. So metals give electrons, and the things that usually accept electrons, we call them non-metals, right? So that's the general idea that we have. Similarly, we talked about covalent bond, that non-metals share electrons with each other. Usually, those things are called non-metals. And similarly, in metallic bond, we said that metals lose electrons, and that was metallic bond. So there's the ionic bond made this way, covalent bond made this way, and metallic bond made this way. And these two, we call them redox reactions, reactions where electrons are transferred or involved, shared. Okay, that is what we said. They are redox reactions. Okay, today we are going to talk about a completely different kind of reaction. And in this reaction, this might be something very new to most of you. It is when protons are transferred. Are protons part of the chemical reaction? Can some such thing actually happen? Kabhi dekha hai? Okay, maybe you have not seen protons explicitly, but you might have seen something else. Let's start with the most simplest atom. What is the smallest atom that there is? Or the simplest atom, not the smallest? Hydrogen atom. In hydrogen atom, you have one proton and you have one electron. Let's say this loses this proton. So if the hydrogen loses this proton, what's left? Just a hydrogen proton with a positive charge. This thing is proton. H positive ion is a proton. That's all there is. Yeah. So I said that hydrogen is the simplest atom. That hydrogen atom has a proton and an electron. Now, if that electron is lost, agar wo apna electron lose kar de, so what you're left with is simply a proton. एक proton center में रह जाएगा बस और कुछ है नहीं. And anything that gives proton, जैसे anything that gives electron, we called it metal. ऐसे ही anything that accepts proton, electron, we called it non-metal. ऐसे ही अगर कोई भी चीज प्रोटॉन दे तो उसको हम बोलते हैं एसिड. And if anything accepts proton, we call it base. So that's all there is. An acid loses a proton, a base accepts a proton. And this reaction is called acid-base reaction. So this is the second major category of reactions. There's the redox reactions in which electrons are involved. They are taken in, they are transferred. And there is acid-base reaction where protons are transferred. Okay. There are other categories of this that you will study in A levels or DP, but we won't get into that at the moment. All right, so let's try to define what is an acid. An acid gives proton, or proton को हम H positive भी लिख सकते हैं, okay, in water. Or you can say that aqueous solution of acid has proton, H positive ion. Similarly, there's another thing called alkali. Alkali gives OH minus in water. Or you can say that alkali has aqueous solution of alkali that has OH minus ion. ठीक है? So what is base? Base is anything that accepts proton. So base accepts proton. That's all it is. That's all what base is. What's an acid? It gives H positive. It donates H positive. What's a base? It accepts H positive. Okay. Now, if the base does this in water, then we call it alkali. Base hoti kya hai? Like what kind of substances are base? So amphoteric substances give or accept H positive. So हमने बोला कि acid क्या होता है? Which gives H positive. Base क्या होती है? Which accepts H positive. ठीक है? Now if anything can do both of them, अगर उसको बेस से रिएक्ट करेंगे तो वो एसिड बन जाएगा और एसिड से रिएक्ट करेंगे तो वो बेस बन जाएगा. मतलब अगर उसको कहीं से प्रोटॉन मिल रहा है तो वो प्रोटॉन ले लेगा और अगर कहीं प्रोटॉन देना पड़ रहा है तो वो प्रोटॉन दे भी सकता है. If something has that quality, that is called amphoteric. So हमारे सिलेबस में there are 4 substances जिनका आपको पता होना चाहिए कि वो amphoteric हैं. वो हैं oxides of aluminum, chromium, zinc and lead. These oxides अगर कभी भी आपको मिल जाए, आप इनको एसिड से रिएक्ट करो, they will react like base. You react them with base, they act like acid. So depending upon what they're reacting with, they behave differently. All right. So now we know what acid is, what base is, what alkali is, and what amphoteric is. The last category of substances that we have is neutral. Neutral को देखने के 2 तरीके हैं. Neutral is when something gives and accepts proton at the same time. Where does it happen? Let's take water. Water can break down and give us H positive and OH negative. Here you can see कि water ने H positive दिया तो water बन गया acid. Water ने OH minus दिया तो water बन गया alkali. But because it is doing the acid part and the alkali part at the same time, water is neutral. In fact, whenever acid gives H positive, so whenever you get H positive from the acid and you get OH minus from the alkali, they make what we call water. And this reaction is called neutralization reaction. Every time you get H positive and OH minus and they react together, of course, H positive will be in water, OH minus will be in water, and they will make liquid water. This reaction is called neutralization. तो इसका मतलब क्या हुआ? Acid का alkali के साथ जब भी reaction होगा, water produce होगा, and that clearly tells me that this is a neutralization reaction. सबको समझ आ गया?
Yes, sir.
Perfect. Let's try a reaction. Let's say I take HCl. Now HCl, what happens when I put it in water? Pay attention, people. This is interesting, especially those who are taking IGCSE, because this is important for you more than it is for O levels. If I add HCl in water, then HCl is an acid. So it will give H positive. But वो H positive किधर जाएगा? It will be given to water. What will water be if I give it one extra H? Right now it says 2O. So with one more H, what will it become?
H3.
Very good. It will become H3O. And then if I give it a positive charge, it will become H3O positive because it got an H positive. And what will be left over? Because this has lost an H, you will be left with whatever is left will be negative. Because उसने H positive lose किया, whatever is left is negative. Now, do you see here that this has become this by losing H positive? So this has lost H positive. Does that make it an acid, alkali, base, or neutral? What does it make it?
Acid.
Perfect. This is an acid. Okay. This
Sir?
thing, yes.
ये एसिड क्यों होता है? ये वाला एसिड क्यों है? इसने अगर H लॉस से अगर इसने किया है ये हाइड्रोजन, तो ये एसिड क्यों है फिर?
सो एसिड को हम डिफाइन कैसे कर रहे थे? हमने कहा कि कोई भी चीज जो H पॉजिटिव दे दे, लूज कर दे, गिव कर दे, डोनेट कर दे, वो एसिड है. सो इसने H पॉजिटिव डोनेट कर दिया, लूज कर दिया. सो ये उस डेफिनेशन के मुताबिक एसिड हो गया ना?
यस सर.
डू यू अंडरस्टैंड दिस? कोई क्वेश्चन तो नहीं है?
नहीं आगे समझ गए.
Okay, great. Now water has accepted H positive, क्योंकि देखो ना, यहाँ पे इसके पास H2O है, यहाँ पे H3O है. So water यहाँ पे बेस की तरह एक्ट कर रहा है.
Sir,
बहुत
but
weird
don't we
बात है.
say HCl and acid? Like HCl consists as an acid.
HCl is an acid, yes, because HCl did give H positive. कोई भी चीज which gives H positive is an acid, and HCl is an acid because it gave H positive. Do you understand?
Yes.
Perfect. Now let's try one more time. Let's say I have ammonia. I add that to water. And now ammonia will make ammonia. And here it will also give me OH minus. Now here's what happened. Where did ammonia get an H from?
From the water?
From the water, yes. So in this case, water is acting as an acid, because water gave an H positive and gave it to this. Notice I told you that water can give H positive and OH minus. So over here, water is giving an H positive to ammonia, and ammonia has become ammonium. Let me write the names. This is ammonia. This is ammonium. So clearly this was NH3. This has gotten one H positive extra. So this has taken it. So it's a base, and that's an acid. Water is acting as an acid. But because water is able to do both of those things, we say water is neutral, because it's able to do both of those things at the same time. Now, one more thing. Is ammonia giving OH minus in water? It is. And what do we call those things? Anything that gives OH minus, what do we call that?
An alkali?
Alkali. Very good. So that means that not only is ammonia a base, it's actually a smaller part of it. It's actually an alkali. Now let's try this. Now this whole thing, this whole process where an acid was breaking down, making something, and the base was breaking down, gaining H positive, this whole thing is called ionization or dissociation. Let's try doing a few examples of this. So I have HNO3. It's a very strong acid. We call it nitric acid. Okay. When I add it to water, because it's an acid, it's going to split. इसने H positive देना है, और जो भी बचेगा ना, जो भी है, that will be negative. So this is going to give me H positive, and whatever is left, I don't care what is it. Whatever it is, I'll just copy that, and that is the negative ion. Okay. Let's try one more time. Let's say I have HBr. Quick, tell me, what will it split into?
H positive, Br negative.
Very good. H positive, Br negative. By the way, does anybody know what this thing is called? So it's called hydro because of hydrogen, and bromic because of bromine. So it is hydrobromic acid. Now here's an interesting thing. If HBr was a gas, I'll call it hydrogen bromide. I won't call it hydrobromic acid. Just like if HCl was a gas, I will call it hydrogen chloride. I will not call it hydrochloric acid. Why? Because an acid is only when it is dissolved in water. If it is dissolved in water, then it is hydrochloric or hydrobromic or whatever you have. If it is not, आप इसको नहीं लिखते हैं. So this thing will split into and these ions, and there you go. Now let's try one more time. I have this thing, CH3COOH. Now this is a different kind of acid. What will this break into? Tell me.
H plus ions and CH3CO negative.
Very good. Have you seen this before?
No.
You haven't?
Yes, sir. Acetic acid.
Acetic acid. Very good. But you see, it does not matter whether we have seen it or not. All we are concerned with is we should take the H positive out. Whatever is left is going to be the negative thing. What should I write? It is dissolved in water. What should I write? Again, all I care about is it an acid? Yes. It will give H positive? Yes. Whatever is left, like if I remove this H positive, whatever is left, I'll just copy that. And that is how it will dissociate. That is how it will ionize. Now, here's the thing. When I add HNO3 to water, if I add 1,000 molecules of this, all of them will break down and give me 1,000 of this, 1,000 of this. If I take 1,000 of this, all of them will break down and they'll give me 1,000, 1,000. But if I take 1,000 of this, maybe 10, 20, 50, 100 of that will make this. Because not all of them are taking part in this process in the process of ionization. I call these things weak acid. And because all of these are taking part in this, I will call them strong acid. So I say that the strength of an acid is how much of it dissociate. Strength is the degree or extent to which an acid or an alkali ionizes or dissociates. We use two words to represent it. Of course, there are numbers for that and there are words for that. If you just want to tell me the words, just like ye zyada hai, ye kam hai. So for that, we have the words fully and partially. If you just want to tell me, is it more or less, you use these words, fully, partially. So if I say, what's a strong acid? An acid that fully ionizes. Okay, what's a weak acid? An acid that partially ionizes. What's a strong base? A base or an alkali that fully ionizes. What's a weak alkali? An alkali that partially ionizes. So I use these words. Whenever you just use words, you're not giving me any numbers. That is these terms, and we call it qualitative judgment. We're just saying कि ज़्यादा है कम है कैसा है. But if I want to give a number, if I want to say how much and I want to quantify that, then for that we have a method and we call that method pH. pH is a way for me to know how much of it has ionized, how much of it is actually taking part or demonstrating कि मैं acid हूं या मैं alkali हूं. And for that, we have the pH scale. pH scale, even though it has a wide range, we will keep ourselves to just between 1 and 14. 1 means it is giving too many H positive and none of OH minus. Almost negligible, nothing of OH minus. 14 means it's giving too many OH minus and almost nothing of H positive. So if you come to this side, that means it's giving more H positive, less OH minus. If you go to this side, it shows you're getting more OH minus and less H positive. So where will both be equal?
7.
7, right in the middle. So smack in the middle, you have 7, and that is telling me you have equal amount of H positive coming out and OH minus coming out. Clearly, that is what we call neutral. It comes back to what we said. What is neutralization? 1, 1 of each of them. That is neutral. The H positive given is the same as OH minus given. But less than 7, that means more H positive are given, less OH minus are given. Greater than 7, more OH minus are given, less H positive are given. So this area, this side is for H positive. This side is for OH negative. And we have a word for it. Anything that gives OH minus, we call it alkaline or basic. And anything that gives H positive, we call it acidic. So there you go. We have defined the region. But then how much? That is called weak or strong. So as I was saying, we have acidic on the left side of 7 and basic on the right side. And we have numbers to specify whether it's more or less. So for that, we have the weak part here for acids and weak part here for bases. We have strong part here for acids and we have the strong part here for bases. Okay, all of that is good, but how will I know it? मुझे कैसे पता चलेगा? I can't see the H positive. It's impossible for me to figure out कि H positive क्या है, कितने हैं. So we have a very simple way of figuring that out. We call those things indicators. Indicators tell us whether something is acidic or basic or what its pH is. There's only one indicator in our syllabus that will help us do that, and that is called universal indicator. So here's how it works. You take the universal indicator, you dip it in the solution. You take a random solution. Let's say you have a beaker of an unknown liquid. You don't know what it is. You dip the pH paper into that thing. The moment you dip it, the pH paper might take some color. Let's say it takes a red color. That color you will match with the color chart. Every universal indicator comes with a color chart. That, okay, blue means 14, green means 7, all of that. So you match it to the color chart and you're like, okay, this must be the pH. So here's how it goes. The pH is 1, so the color will be a dark red. The pH is 7, the color will be a green. The pH is 14, it's a deep purple or violet. And then, of course, the colors are the rainbow colors. So orange, yellow, green, blue, indigo, violet, all of that. And based on this, we can easily figure out what the pH is. So what's the method? If you were to write it down, that dip the pH paper in the solution. Or if you don't want to do that, if you have a liquid indicator, then add a few drops in the solution. That's your first step. Second step, match with the color chart. Usually it's a 2-mark question of how you will figure this out. And remember, it's only the universal indicator that we can use to figure out the pH in our syllabus. So what are the other indicators for? There are plenty of other indicators. There is the litmus. There is the methyl orange. Okay. there is the bromothymol blue. Now, these indicators, they are just telling me whether something is acidic or if it is basic. That's all. These cannot tell me what the pH is. Okay? The only way I can use these and the only information I can get from these is by knowing whether something is acidic or it is basic. Now, bromothymol blue is not in your syllabus.
Sir,
But
is phenolphthalein included?
phenolphthalein is not, thymolphthalein is. Okay? So phenolphthalein is not in the syllabus anymore. Thymolphthalein is. Okay? And this is only for IGCSE people. O-levels people just need to know about litmus and methyl. IGCSE people need to know about all three. Okay? And the colors are like this. The color for litmus, as you know, what's the color for litmus in acid?
Red.
Red. Very good. Okay. What is methyl orange in acid?
Red.
Methyl orange is actually yellow. Okay. And what color is thymolphthalein? It is colorless. Now, what about base? What color is litmus in a base?
Blue.
Blue. Very good. What's the color of methyl orange in base? It is red, or you can also say pink. Now, I know we might be enticed to say orange because orange is in the name. But basically, the color orange exists very close to 7. So like a weak acid might be orange, a weak base might be orange, and the neutral will also be orange. So for that reason, we usually don't specify that it's orange because we can't say whether it's acid, base, or neutral. We usually can't. But yellow and pink clearly tell us, or red even, clearly tell us whether it's acid or base. And for thymolphthalein, the color are colorless to blue. So just like litmus, it is blue in the base, but just like phenolphthalein, it is colorless in acid. So in
Sir,
acid, yeah.
in our chemistry book, it's written that methyl orange in acidic solution is red.
Okay, then I might be writing the opposite way.
It's in chemistry matters.
I will take that. I will flip them like this. My bad.
Sir, base and alkali are the same.
What do you think?
Like you didn't mention alkali in the pH table, so I think they are same.
So what makes any base an alkali? If it dissolves in water, it is alkali. If it doesn't dissolve in water, it's not alkali. Thank you for specifying. Methyl orange is red in acid. Now, phenolphthalein is not required for you to memorize, but we use it all the time. The problem with phenolphthalein is the color change is very subtle. Like a pink color, it goes from colorless to pink. It's really subtle. And many students struggle with getting that color. So that is why in IGCSE, they recently changed it to thymolphthalein. But for O-levels, the things stay litmus and methyl orange. You don't need to remember the thymolphthalein. Clear, everybody? So now we know what the indicators are, how to use the indicator, and how to use all of this to figure out. All right. Any questions so far?
No, sir.
Perfect. Now I'm going to introduce you to a very important concept. And that is ATP. How is this tested in the ATP? Like, how do I know whether something is neutral? So in ATP, let's look at the neutralization thing. They make water. The H positive might come from acid, let's say HCl. The OH minus might come from an alkali, let's say NaOH, and it makes sodium chloride and water. We will do the exact reactions tomorrow. But here's the thing. HCl is a solution. How can I find out the concentration of that solution? What is concentration? Concentration is how much acid you have added to the solution. That's all. How many moles of acid you have added. Now, the formula is N equal to Cv for both of them. And what does the equation tell me? You take 1 mole of this, you react it with 1 mole of this, you get water. Which means that whatever moles I have of this, the moment I get the same moles here, I get neutral solution. Okay? But how do we do that in the lab? It's easy to do it theoretically, but how do we do it in the lab? So here's the thing. For one of these, we will need to know the concentration. So let's say this concentration is known. So what we do is we take some volume in a pipette. Kyun? Because the moment I know the moles of this, I will know that that many moles of HCl is required to react completely. That is the number of moles required to make water. So I can measure the volume through pipette. I can measure the concentration in if it is given, because मैंने solution बनाया, मुझे उसकी concentration पता होगी. मैंने कितना NaOH डाला है मुझे पता है, मैंने weigh करके add किया. Now, can I use that to figure this out? The concentration of HCl. We can. Here's what we do. We take NaOH, we add it to a conical flask. क्यों? मुझे बस ये देखना है, the moment moles of this equal moles of this, वो neutral हो जाएगा. और मुझे अगर किसी तरह से पता चल जाए ना कि ये neutral हो गया है, I will stop. There is a way for me to know whether it is neutral or not. That's an indicator. So I will add an indicator. And now I will add the HCl into this thing, drop by drop. So I will add enough volume कि moles बराबर हो जाएं. So I will use a burette to add alkali into this thing. So I'll add burette to add acid. I already have alkali. The moment there's a color change, I will stop. But because I'm only human, I can make errors. So I will take another one, and then I'll take another one until I get a consistent value. So if I get it 16.3 centimeter cube the first time, maybe next time I'll get 16.5. Maybe the next time I'll also get 16.5, which tells me that, oh, you have repeated it. This must be the correct value. So I take the average because this reduces my error, increases my accuracy. So I got the volume of alkali from the pipette. Concentration was given to me. Volume of acid from the burette. And number of moles from mole ratio. Why? Because if I know moles of this, 1-to-1 ratio, wohi iske moles honge. So now I know moles, I know the volume. I'll simply divide it to figure out my concentration. And that is a 12-mark question in ATP exam. That is it. All you have to do is volume pipette से लेना है, concentration पता होगी. दूसरी concentration burette से लेनी है, average करनी है. Use that and the mole ratio from the equation. क्योंकि 1 mole ये है तो 1 mole ये है. अगर H2SO4 है तो H2SO4 plus 2 NaOH. So that means if this is 2 mole, this is 1 mole, use the ratio method, whatever the answer is. You know the moles from calculations, you know the volume from the burette, you divide it, you get the concentration. And that is it in the ATP. I'll send you a question for ATP. Try that out. Try to see if that makes sense to you. क्या करना है? You start with any one of these. उसकी concentration आपको पता होगी. उसकी volume आप pipette से देखेंगे. Fix होती है 10, 25, कुछ एक fix कर देता है वो. And then the second one you get from the burette, the moles you get from calculations, you use that to find out the concentration. And this whole process is called, does anybody know what this process is called?
Titration.
Titration. Very good. Tomorrow we will do reactions of acids and bases. And yeah, thank you so much. I'll see you tomorrow.